Hi there and welcome. Today on the bench we have this VTech Laser 50. It wasn't very popular in Europe, but the big brother, the Laser 100, was, I wouldn't say popular, but it was known. This is the little brother, and we're going to take a look at that today. And then in the future we're going to look at some other VTech machines. The thing about VTech is that they did initially use Microsoft Basic in their machines, but what happened was that when Microsoft got around to doing DOS, they weren't interested in these little guys like VTech here. They were making so much money on DOS that they just couldn't be bothered. So the company VTech initially had some really nice machines up until the VTech Laser 310, I think, or was it called 320? But after that, this company kind of deteriorated and started making some toys and what have you without the Microsoft Basic. And I think they're still around today. Now they're making kids' toys, and that is also fine. It's just not interesting for people like ourselves. And so here's the manual. It looks practically brand new. It has barely been opened, and there are some little examples on how to program. And as you can see, it's a nice little handheld device. It has a display up here. I think this is a 16 by 2 lines. It has a keyboard, which actually is not bad. The keys are a bit plasticky, but the feel is pretty good. On the back we have a battery compartment. No, we don't. So this is some kind of a memory module that can plug in here with additional features. So not bad. And down here must be the battery compartment then. And this takes 4 AAAs. So that's pretty good. A nice little design here. Whoops. Maybe, yeah, okay. Did I say that too soon? Yeah, that is a bit tricky. How on earth? Oh, okay, there we go. So that's it there. Then we have a little handle. You can carry it around. Look a little bit camp with that. But otherwise, okay. Then we have on each side a couple of legs here, so that it can raise the back for better typing. On the left there's an on-off switch. On the front there's nothing. On the right there's nothing. And on the back we have power in, cassette in and out, and something for a cartridge port, I think. But of course this one comes with all the material, so maybe we can get an idea here. Yeah, I'm not sure you can see that. Yeah, there we go. So there's a laser printer. There's a laser printer. Yeah, so there's a cassette, and we saw the interface for that. Then there's a laser printer, as I said, and a memory expansion box. 4K memory. Wow. So I guess the little plug at the back there is for the printer. Anyway, a pretty neat little machine. And of course, what was missing on the back of this machine was the TV output. And I think that, so I can't use my this machine, and I guess I sold it as a long gate for learning visual base. Of course, the machine, they did manage to generate TV out, and I became later 100, and they the machines. And that was... Oh, what's happening? Something stuck. There we go. There wasn't any screw after all. So let's take a look inside, and well, that looks horrible. Horrible, horrible, horrible. There are some brown PCB, it's not even fiberglass. And that's the keyboard, of course. And then there's some enormous bodge, one ginormous bodge, and I don't even know what that is doing. Holy crap. It's just a lot of wires. A little trimmer, some transistors thrown in with a shovel, and then with some hot snot glued all over. And I guess this is the computer, this little PCB. And if you look at it, the PCB is bent like hell. I have never seen anything this junk in my life. I mean, the whole thing is just, wow. That is amazingly shit. Wow, that is awful. Is it all together, is it? Yes. Oh, that's computer. Unbelievable. Okay, so that's not the way to get it out. We have to remove this one here, which I think is, apart from all the bodge, apart from all the wires, I think this is the PCB for the LCD display. And that makes sense. They have a little switching something for generating the negative voltage for the contrast for the display, which was the norm back then. There was not any. Okay, there's all right. Incredible. Unbelievable. Unbelievable. Incredible. So there we go. Is it coming out? Yes. Aha! There we go. And I think I ruined it. Look at the display. This is using those zebra strips, and that is impossible to get back together again, I think. Okay, so I've been googling this stuff, and there is no information about these chips whatsoever. But there are two Toshiba chips here. One is called the T7812A, and the other one is called T713A. And I cannot find anything online about these chips. But it looks like something that could have been used in a washing machine or something like this. The date code is week 14, 1985. But yeah, as you can see, the build quality is absolutely horrible. It's all single-sided PCBs with the solder mask that is already peeling off. And all the top layer is just done using wires here. So yeah, the labor cost that they had, VTech must have been extremely low, because it was cheaper to have some guy sitting and soldering these wires in than getting a double-sided PCB. Also, the PCB is not fiberglass, as I said, it's paper phenolic, which is absolutely junk. But anyway, that's it. I will see whether I can plug it back together, because now I have, I guess, opened it up, and yeah, the display, I'm a little bit concerned about the display, because this is just zebra strips and it's very easy to ruin. I got it back together and plugged it in, but it is not working, and I think that's not surprising. In fact, I should be able to see something in the display, but there's just half of it with some pixels and half of it without pixels, and I can't get anything running on this thing. Oh, hang on. There's a little P0 flashing here, and there's a cursor. It's almost working. So the only thing wrong, I think, is the zebra strip. I'm not sure if you can see that. I can hardly see that. That is amazing. There is life in this machine. Okay, so I managed to get it back together, and it actually works. But the display is practically not visible. And the only thing I can think of is I flipped the polarizer the wrong way around. But it should not make any difference. Normally if you do that, like with black, shouldn't make any difference. Make any difference. So I'm not sure what's happening. How do I get that out? Alright, that's why it's complex. There we go. So actually it looks pretty decent. The zebra strip is still working, but maybe I should flip the polarizing filter. If I can get everything out again. I don't understand, they didn't do this as a little module, but maybe maybe they could save a bit of money doing it like this. So I'm going to filter. I'm going to there we go. And I can filter. So that should be all around. Very strange. Let's just look at it from front. That was really dark. That can't be right. It can't be right. So like this. And I think that's the way I do it. Still makes no sense. Makes no sense. Still secret chunk. No clue what's happening here. No clue at all. So I think we'll just put it back together and consider working. Except it's almost invisible to display. Unfortunately. Okay, so finally I figured it out. There's actually more than one layer of polarizing film in this display here. So yeah, I got everything working amazingly, considering the shitty quality of everything in this machine. But it's working, and there's only 2 chips in here, 2 Toshiba custom chips. LCD controller, CPU plus mask ROM and RAM as well in just two chips, and a keyboard controller. So that is pretty amazing. I mean, the base board is just like this. There are a couple of diodes here for the keyboard, which is similar to the Sinclair way of doing things. Then there's a little circuit up here, as I probably said earlier, that generates a minus supply for the LCD contrast. And then there's a little voltage regulator thing here for the power supply. And that's it really. And this board here, of course, is a memory expansion. There's a RAM chip here with 2K of RAM. There's a little connector on the back here with gold fingers, which is not too bad for a printer. And then over here at the back there are additional memory expansion capabilities. Design-wise, it's actually pretty good. 2-chip solution. I think that is excellent. Of course, using the Toshiba technology, but anyway, it's still pretty decent. And also, I mean, you can consider this in 2 different ways. You can say this is probably the shittiest quality that you have ever seen, with warped PCBs and wires going here and there, hand soldered in. But from a cost perspective, this is actually pretty decent. And these wires are not going anywhere. It's a weird kind of assembly technology, but it's actually quite sturdy, and I think you can throw this machine around quite a bit without anything happening to it. So, I mean, it's really unusual. It's really, really unusual. But still, it works, right? Which I think is pretty amazing. I mean, if I had to do something like this really, really cheap, and I had very, very cheap labor cost, I'd probably end up doing the same, except for the warped PCBs. Very, very interesting, a very, very different take on how to do a low-cost machine. 10, print, print. Hello world, here we go. Hello. I don't know how to backspace. Hello world with a single L. Enter. 20. Go to 10. And we should be able to run it. Run. Boom! Hello world. And it's excellent. With a very sharp display and everything running. But can you learn programming on this? I guess if you have the time and the interest you can. But yeah, not a bad little machine. It's just a very weird manufacturing process. But I like it. Actually, after all, I like it. So yeah, that's it. Thanks for watching, and see you again soon.